Calculate the distance of the planes given below from the origin. So we have r dot 2, negative 2, 1 equals 12, and r dot 2, negative 2, 1 is equal to negative 21. So first thing to note is the normals are in the same direction, 2, negative 2, 1. If you had negative 2 to negative 1, the best thing would be to multiply both sides by negative 1 so that the normals are in the same direction and not one that way and one that way. We worked these ones out in a previous example, and we found that the distance of this one from the origin was 12 divided by 3, which is equal to 4, 3 being the magnitude of this normal. And for this one, when we did the initial calculation, we got negative 21 divided by 3 is negative 7. So we gave the distances as 4 for this one and 7 for this one, but we talked about the positive and the negative, and that means, as we just discussed, that they're on opposite sides of the origin. One of them is 7 units this side, and the other one is 4 units this side. Therefore, the distance between the two is 11 units. When we did these ones in the previous example, so we've got r dot 3, negative 2, negative 1 equals 28, and r dot negative 3 to 1 is equal to negative 35. The first thing we did was change this one by multiplying both sides by negative 1, like so. And that makes sure that the normals are in the same direction. It just cuts down on the chance that we'll misinterpret. This one, when we worked out d, it turned out to be 2 root 14. And for this one, it was 5 over 2 root 14. Both were positive, the same sign, and that means that they're the same side of the origin. So this distance here was the 5 over 2 root 14, and this distance here was the 2 root 14. And so the distance between the planes is just 5 over 2 root 14, take away 2 root 14, which ends up being a half root 14.